I decided to do my topic on ocean acidification, mainly because I live right on the coast in New Jersey, so I'm always at the beach and in the ocean. And I didn't know the importance of this topic, so I want to research a little bit further and see what one of the main causes of climate change is today. So just to recap, we already talked about acids and bases and the pH scale earlier in the semester. So basically the pH scale goes from 0 to 14 and it measures whether a substance is an acid or a base. So on the scale, 0 through 6 would mean the substance is an acid. The lower down you are, the more acidic it is. And 8 through 14 is a base. The higher up you go, the more basic it is, or alkaline as we would say. And right in the middle would be a 7, which is right in the middle of acids and base. It's considered neutral, something like pure water. So an acid is a substance that donates hydrogen ions to water, while a base is a substance that donates hydroxide ions to water. So a couple examples of an acid is lemon juice or a soda, while a couple examples of a base is cleaning products such as bleach, toothpaste, soap, and things along those lines. So now that I went over what acids and bases are in the pH scale, we can get into what ocean acidification really is and the causes behind it. So by definition, ocean acidification is the decrease of pH in seawater worldwide, causing the oceans to become more acidic. And this is due to the excess carbon dioxide that is released into the atmosphere. So ever since the Industrial Revolution, more than 400 billion tons of carbon has been added to the atmosphere. And about 30% of this excess carbon has been absorbed by the ocean, which is 120 billion tons of carbon. And this is due to the fact that we are burning fossil fuels at a record rate, the amount of cement that we are producing, other human activities such as cutting down trees and other things that are harming the environment and furthering climate change. So due to all the extra carbon that is being produced, it is hurting the ocean and causing it to become more acidic. And carbon isn't necessarily such a bad thing due to the fact that plants do need to undergo processes such as photosynthesis and respiration and those kinds of things. But when there's too much carbon, which is what we are at today, it throws off the ecosystem. There's an imbalance between the amount that we should have and the amount that we do have. So the excess carbon does have to go somewhere. And unfortunately, about 30% of it does get absorbed by the ocean. So in the 1700s, the pH of the ocean was more alkaline at a pH of about 8.1. But now ever since then, there has been a 0.1 pH drop since the Industrial Revolution due to all that excess carbon that we are producing, which means it has become 28% more acidic because it is a logarithmic function. So a 0.1 change in pH causes a 28% change in how acidic the ocean really is today. So this diagram right here shows basically what I just talked about. On the left, we have dissolved carbon dioxide, and on the right, we have the ocean pH. The blue is the historic levels. It was made in 2005, so in 2005 we're right about here. And this is if we kept going at the rate of the carbon emissions that we're releasing into the atmosphere today. So it goes from 1850 to 2100, and on the right side we have the ocean pH. As I said before, right at 1850, the ocean pH was about an 8.1. And now in 2005, it was about 8.05. So if we keep on going till 2100 at the same rate that we're on right now, the pH of the ocean will be at about a 7.85. And as I said before, a 7 is neutral. So we're getting to the point where it's cutting close with being more actually considered an acid instead of a base. So now we'll get down to the chemistry behind the salt and why it's actually happening. So as I said, the CO2 is being released into the atmosphere and absorbed by the ocean. So by a chemical reaction, the CO2 combines with the H2O, which forms H2CO3, or carbonic acid. And then due to partial dissociation, the carbonic acid breaks down into hydrogen ions and HCO3, which has a negative charge, or bicarbonate. And due to, as I said before, an acid is something that donates hydrogen ions to water. So due to the increase in hydrogen ions in the ocean, the pH of the ocean is reduced, becoming more acidic. This diagram on the right shows the same exact thing. The carbon dioxide comes in from the atmosphere, it turns into dissolved carbon dioxide, and it mixes with water, H2O, forming carbonic acid, and that partially disassociates into hydrogen ions and carbonate ions. So now we'll go into some of the effects that ocean acidification is causing on marine life and ocean life. And as I said before, since there's more hydrogen ions going down, there's no calcium carbonate, which brings us to the first effect. Due to the decrease in calcium carbonate, marine organisms have difficulty forming their shells. Due to the fact that their shells are mainly made out of calcium carbonate, almost the entire thing is made out of this calcium carbonate, there's not much left, and marine organisms cannot really form their shells, which is crucial to their survival. Organisms that already have their shells, if they're a little bit older, may have them dissolved, and they're going to have to spend all of their time and energy remaking their shells instead of being able to reproduce and grow themselves. Other organisms have to shrink a little bit just to survive because all of their time and energy has to be put into their shells rather than being able to grow. So they'll just become smaller, which has a lot of effects on the food chains and food webs in the marine life. A little bit more. So coral reefs also become more susceptible to storm damage because the skeletons take a longer time to form and grow and recover. If there's any change into the environment, there's a slower recovery time. It also confuses fish by disturbing their sense of smell, and it changes the ways that sounds transmit through the water. So this diagram shows everything that I just showed you. The carbon dioxide comes into the ocean, causing ocean acidification, and as you can see the clownfish right here, it damages its senses and it has trouble finding the coral reefs, which are already broken down because the skeletons are unable to form. So now they have no habitat to live in, and their sense of smell is already disturbed, which puts them at risk to predators such as sharks. And this will really hurt the food chains in the ocean because clownfish are towards the bottom of the food chain, so once they start to disappear and become endangered and eventually extinct, organisms such as sharks and the bigger predators become endangered and extinct because they have nothing to prey on anymore. So now you might ask, what's going on with the future? What happens if we do continue emitting carbon at this rate? Because really there's not much we can do unless we want to stop emitting so much carbon, maybe stop factory production, try to live a little bit greener, as people would say. But basically, if carbon emissions are released at the same rate until 2100, the ocean's pH level will decrease between 0.3 and 0.5 more units, or down to a pH of 7.6 to a 7.8, as I said before, which is getting closely dangerous to an acid instead of a base. Organisms such as phytoplankton and zooplankton may not be able to survive, collapsing food webs. As I said before, organisms such as whales completely feed on krill and other stuff like this, and they rely on them completely to survive. So once smaller organisms are gone, it will completely endanger all organisms in the food web of the ocean today. So now, I have a little bit of a video to show you that basically summarizes everything that I just talked about. Right here. So now that you have seen the video and the summary of my PowerPoint, you know the importance of ocean acidification and how we really need to do something now to stop it. And as I researched, one of the only solutions that I could find is if scientists were able to capture some of the carbon dioxide, emit it into the atmosphere, and put it away in storage somehow. But besides that, there's not really any way that we can get rid of the carbon dioxide unless we reduce the emissions that are being emitted today and slow it down to 2100 to save our oceans, save the marine life, and save society as it is today. So thank you, and that's all I have today.